Hi, I'm Tim Berglund with Confluent. I want to talk to you today about WarpStream. And to do that, first, I want to take a look at how it is we run software in the cloud. Suppose you want to run the Confluent data streaming platform. You've got Kafka, Flink, Connect, governance, the whole gang. And what you want to do is you want to run this yourself in your own cloud account. Okay, so you're going to go get the appropriate Helm chart or download images, whatever it is you do, and you're going to stand up some servers in the cloud. You're going to allocate some storage of some kind, lots of details to work out there, right? But you're just going to run this yourself, and we'll call this the traditional self-managed cloud deployment. And I'm going to say this is all in your cloud. Great, right? You have control over the security story, the costs, it's all visible to you, it's great, but it's a lot of work. Maybe you don't want that life. Maybe you'd rather try Confluent Cloud. Okay, so in Confluent Cloud, that's a fully managed cloud service. So the whole data streaming platform is there, elastic scalability, nice web UI, command line tools if you want them, Terraform provider if you want to be a bit more civilized, and it's wonderful. How does that really work though? Well, all right, there's going to be the same kind of thing. There's going to be compute, and there's going to be storage, and there's this other layer of, we'll say, compute and maybe another little bit of storage that kind of implements the UI and all the elastic scaling and everything. We'll call this the data plane, and we'll call this the control plane. So that nice web UI, the command line tools, all that stuff, you're really talking to the control plane there, which is manipulating the data plane. And this can run in whatever availability zone, whatever cloud provider you want. But in the case of this kind of offering, this fully managed offering, this is all going to be in the same cloud account that's going to be Confluent's account, right? Carefully managed by Confluent SREs. It's great service, but this is what we'll call the traditional software as a service approach, where it's all in the provider's cloud account. Now, what if you wanted both? All right, you say, I love this, love the interface, the elastic scalability, everything's wonderful, but I want the data plane to run in my cloud account. So, I've negotiated special pricing, or I like the simplified security story, or whatever. Well, that is what we call BYOC, or bring your own cloud. Now, it's the same kind of diagram here. We'll say, there's a data plane. Here are those servers. Here's some storage, right? This data plane is there. Being a data plane, there's a control plane, certainly, right? There's going to be compute. There's going to be some state in that control plane. Control plane, we'll draw a box around there. We've got a data plane here, didn't label it. There you go. So there still is a control plane and a data plane, but what's different is now the control plane runs in the provider's cloud account, and we'll use a new color for your cloud account. So this is your cloud, and this is the provider's cloud account. So we split them up. Now, the provider here is, of course, going to have to penetrate over here into the data plane. The control plane is going to have to do something to manipulate this data plane, because there's all these nice UIs. You're saying, hey, I want this cluster, this sort of metadata, whatever it is. The control plane is going to have to tell the data plane what to do and have some way of breaking in there. And sometimes that connection can be kind of sometimes a little scary, because for this vendor to be able to fix problems, if this is complex stateful infrastructure in here, they're going to have to be able to, as it were, break glass, get in there, re-weld the thing, get the wetsuit on, get on, whatever it is they have to do to fix things when they go wrong. So there is a simplified security story and maybe a cost advantage, but in some traditional BYOC implementations, the security story isn't really as good as we'd like it to be. We can do better, and that better is WarpStream. WarpStream is BYOC, only more so. to explain what that means, let's go back and talk about a Kafka cluster, a traditional Kafka cluster. Like, forget about the cloud for a minute, right? What do we have here? So this is traditional Kafka. And what do you have? You have servers, and each of those servers has disks on them. Let's draw a few. It's a distributed system. We can do that. So here is our Kafka cluster. These are brokers. And when you create topics, they store topic data on local disk. All right. And that's great. That's a fast connection between the processor here and that disk. That's the other end of a PCI channel. It just doesn't get better. So you've got nice, fast, low latency access to disk, but you're doing a lot. This is not particularly cloud native, this traditional Kafka here. There are various ways of adapting that into the cloud, but imagine you wanted to start from first principles. Like, okay, what does it mean to be Kafka? There are some APIs. Let's implement those APIs. There are some semantics. Okay, we're going to have partitions and be a distributed log and so forth. So if we want to enforce those semantics and implement those APIs, but we want to do it in the cloud and forget that this is even a thing, what would you do? Well, you wouldn't use disks. Is there no storage in the cloud? There is. There's S3 or enter blob store of your choice. And it's great. It solves a lot of the problems that brokers otherwise have to solve. Like, a lot of the work of being a broker is replicating changes that get written to one broker. They have to get copied to the other replicas and manage, and something goes down, you have to copy it over. You've never thought about that anytime you've written anything to S3 because the service does it for you. And if your volume of data grows, well, you have to add more brokers in traditional Kafka. You've never thought about scaling S3. And maybe as a joke, you've talked about using up all of S3, but you're not going to do that. You can allocate more storage and it's going to be there. It's going to be replicated. So right away, if you took that approach, like, let's use S3 for our cloud native Kafka, you're going to greatly decrease the operational complexity of the cluster. It's going to be easier to run, and you're going to put a probably higher upper bound on scalability. Maybe you'll save money too, because S3 tends to be a cheap way to store data in the cloud. A popular one too, by the way. This is where the data lake lives. All kinds of batch data is stored here, and all kinds of real-time data. If you use Confluent Cloud and tiered storage in a topic, where do you think that tier is? It's in blob storage in the cloud provider of your choice. So this is a very common place to put data. One problem with it, though, is it doesn't act like Kafka. It acts like a file system. There's no logging, semantics here, or anything like that. So what WarpStream does is introduces a component called the WarpStream agent. So we'll just draw a few of these. These are scalable components. We can have many of them. Let's just draw a few more. We'll say there's a bunch out there. These are stateless components, these servers that are running here, that talk to the blob storage in the cloud and make it look like Kafka. So on the front here, they're implementing or exposing a Kafka API. Same thing down here. And so anybody on the outside, any application, anything you've got that expects to be talking to Kafka can talk to one of these WarpStream agents in this pool here, and they get what looks like a Kafka cluster. These being stateless, they're easier to manage. So this concern here, where you have to have folks at the vendor be able to break in and see what's going on and fix problems, we don't have that. There is no way for Confluent SREs or operations personnel to break glass and get into your cloud account. By the way, I should demarcate that so you know for sure that this is all your cloud. To deploy these, we give you a Helm chart. You present that to the managed Kubernetes service of your choice and set these to auto scale on CPU. And because they're stateless, they're a lot simpler. That whole part of your operational responsibility, which is always something that you take on a little bit of when you enter the world of BYOC, that part of your life is so much simpler. Now, of course, there still is some kind of control plane, right? We don't get away from that. It's still a cloud service. There's a UI. There's something you do, and what you do here is really metadata maintenance, right? You're going to create clusters, modify partitioning, create topics, that sort of thing. And these agents here go out and ask the control plane for metadata changes. It doesn't have any way of getting into them. And this is, of course, in Confluent's cloud, because we still have this dichotomy between the provider's control plane cloud account and the data plane, your cloud account. And that's not an idea that WarpStream has invented, but it is a concept that WarpStream has carried to its logical conclusion to really deliver on the security promises that BYOC offers. It does that in a very credible way. And by pushing all of the persistence in a Kafka cluster into S3, it makes it radically more scalable and lower cost. Now, there has to be a trade-off there at some point. As I mentioned, this connection to local disk, very low latency, very fast. You're never going to get better. Even cloud deployments, sometimes that connection gets a little more subtle. Over here, obviously, S3 latency is going to be higher. So the trade-off you get for the security posture, for the scalability, for the low cost, is one of latency. So you have to pay attention to that, and you have to know, does your application require a certain latency SLA? Can that be met here? But you know what? It's nice as an engineer to have control over trade-offs like that and actually have choices to make. I'm always a fan. So that is how WarpStream works. It's BYOC carried to its logical conclusion. It's cloud-native Kafka in an extreme way with S3 for storage. It's BYOC only more so. So if you want to know more, you can always hit us up in Confluent Community Slack. You can find us at a meetup, or you can, as always, online, head down to the description. There is a URL in there. Hit that up. There'll be more resources about how to get started with WarpStream. And as always, and especially in this case, I look forward to seeing what you build.